Okay, welcome to 1.3, page 4. We're going to get right into this. Determine the open intervals on which the function is increasing, decreasing, or constant. So clearly our function here on 24 is decreasing until here. And it's a later study for us, but it would not be too hard to convince you that that actually must be the point 2, negative 4. But at this point, I'm not interested in going through that. So other things to note, for instance, like this point over here on 25, this minimum looks like it's at 2, negative 2. You can assume that's the case. You can assume this one's at 0, 2. That'll be a big player in our answers. So the common mistake answer would be to say, well, this is decreasing from up here at infinity down to negative 4. So to say infinity to negative 4, it's decreasing, then it's increasing from negative 4 to infinity. And I understand why you would make that mistake, but it's a mistake nonetheless. For intervals, we want to scan from left to right along the x-axis. So this graph is decreasing until we get over, not down, over to 2. So here we go. It is decreasing from negative infinity over to 2. And then it starts increasing from 2 over, not up. It's increasing as x, the interval goes from 2 to infinity. Okay, now 26 decreases, then looks like it doesn't exist, and that's worth taking a look at, and then increases. Or maybe it's constant through here, maybe it just connects. However, 0 for x, if I put 0 in here, it doesn't take long to figure out we got problems. And if I put 1 in for x, we almost have problems. When I put in 1, doesn't take long, we get 0. Negative 1, we also get 0. In fact, this function is even. Whether I put in a positive or negative, it's the same height to the right as it is to the left. So this graph decreases from negative infinity, always left to right, until we get to negative 1. And yes, we actually use parentheses there because it's not decreasing at negative 1 anymore, because in one direction it's just stopped. And then it increases. It starts to exist again at positive 1, and then starts increasing forevermore. Not up to infinity, but over to infinity. Good news. The next section is exactly the same without the graph, and they're going to let us use our graphing calculators. Determine on open intervals which of the functions is increasing, decreasing, constant is added to this. So if I have a function that comes up, goes straight across, then goes up, it might be increasing, constant, increasing. Whoops, can't see it. Increasing, constant, increasing. Okay, I'm not going to use my calculator on 28 because I'm pretty sure I know what the graph of y equals x plus 0 looks like. Y-intercept 0, slope of 1. It looks like this. From left to right, it is always increasing. From negative infinity to infinity. That's our interval notation. When they ask for intervals, we're going to give interval notation. But we might not know what the graph of this one looks like. So y equals clear. This is going to be negative, the opposite of x to the 3/4. You could put 0.75. You could enter that 3/4 as a fraction with alpha window, or alpha F3, alpha window, yeah, F2. Okay, so I'm in zoom standard. I'll make sure zoom 6. 6 is standard, so I'm hitting 6. Negative 10 to 10, negative 10 to 10. And it looks like this graph just stops existing around 0. Let's take a look at the function. Well, this is actually the same as negative 4th root of x to the 3rd. And we'll talk more about kind of parsing that out like that at later times. So let's think about that. If I put a negative value in for x, then I've got issues here. issues with my computer right now. If I put a negative value in for x, I can't take an even root of a negative number. So I can put in 0 and I get 0. So reminder, when you are asked to use your graphing calculator, I'm going to have you go ahead and sketch the graph just so you're being assigned odd numbers. I want to know that you're actually going through doing the work. Okay. So this graph is just decreasing. It begins at 0 and then starts decreasing forevermore. Not 0 to negative infinity, but 0 over to infinity is where it's increasing. Okay. Number 32, y equals clear, x second square root of 3 minus x. Now, just anticipating, I expect 3 to be a pretty interesting point on this graph, because when x is 3, we get square root of 0. When x is 4, we got problems. In fact, when x is 3.001, we've got problems. Can't take square root of a negative. Let's graph it and see if that holds true. So we got a graph that appears like it goes through 0, 0, comes up, comes back down, and kind of stops here, but sometimes our calculator might be lying to us. It looks like it's stopping near 3. I'm going to go trace, and I come over to here, tracing over to here, where x is 1.2, 1.7, or 2.7, 2.8, 3.03, and y doesn't exist. I suspect it's at 3, but I think I can just hit 3 and enter. Oh, 3, 0. The graph kind of lied to us there. It really gets down to 0 here. Okay. Now, therefore, we know this goes through an increasing phase until somewhere in here, and a decreasing phase. And you might say, well, it must be halfway between here at the top. Actually, even on my calculator, it doesn't look like that's the case. So how high up is that? Or how far over is it? It's somewhere close to 2, it looks like. For our calculator, we can go second, calc, and then this point right here is a maximum. So I'm going to look for that maximum. It's the most expensive house in the neighborhood. It asked me to get to the left of that maximum. Okay, I'm definitely to the left here. Hit enter. Get to the right of it. Make sure you don't cut it too close. Get past it so it's coming down. Hit enter. Guess? No, just tell me. Hit enter. And it tells me it's at 2.0000003, something like that. When that happens on your calculator, it's generally safe to assume it's the integer. If it rounds off sooner, or if it doesn't extend that long, just round to 3 decimal places as a general rule. So we are increasing as we go from negative infinity over to 2. And then we are decreasing only from 2 until we get to 3, because it stops there. And this 34 is really a nice little problem. Y equals clear. Negative. Absolute value. You can get there with second catalog, and some people do that. But I would encourage you to get used to alpha F2. Oh, is it alpha F2? Yep, there it is, absolute value. Alpha F2. And we hit enter. We got absolute value. X plus 4. Step out of there with cursor. Minus alpha F2. Absolute value. X plus 1. Definitely would not expect us to know what the graph of that looks like. However, we should expect interesting things to happen around negative 4 and negative 1, because that's when the absolute values are 0 and they can't get any lower than 0. So let's graph that in Zoom Standard. And sure enough, 1, 2, 3, 4. 1, 2, 3, 4. It looks like we're just flat around 3 from here to here. So our graph looks something like that. Again, I just want a pretty decent sketch of what your calculator shows you. And now I'm going to go ahead and trace this thing, and I'm going to just zip back here real quickly. As you can see, we go through scanning left to right. We're going up. We're increasing. We get up to here, and now it looks flat. Is it flat? It sure is. Y is staying at -3. And then this would be at -1. We know that by looking at the function. At -1 is when things are going to be interesting. At -4, things are going to be interesting. So we are increasing from -infinity until we get to -4. We are constant from -4 to -1, and we are decreasing from 1, not down to -infinity, 1 over to infinity. Notice 3 isn't in here. 3 is a y value of interest to us, or -3. It's all x values, -infinity to -4, -4 to 1, 1 to infinity. So there you have it. I think you could probably agree that you should be able to get through this section probably quicker than you did with me going through explaining it all. So let me know if I can help you, and stay tuned.